Hello guys, welcome back to Maison African Motives, still on Mathematics N3. In this platform, we shall be focusing on the question paper which was written in April 2023. So we shall see how we're supposed to attempt these typical questions. So the first part on question number 1, we are given factorize the following as far as possible in prime factors. That is question 1.1. All right, so let's see how we're supposed to attempt this typical question. So that is 1.1. We are given px squared minus x plus y into 1 minus px like this. All right, so this is what we are asked to factorize. So if you are to check in this question that you're given, already they have done a factorization for us in this bracket here. We have already, they've already factorized y, which is common. So what you're supposed to do is, in this case, is to factor out what is common between these two terms so that we are going to obtain 1 minus px. Remember, by grouping, we are supposed to obtain the same bracket. So as you can see, p is on the first term, yet here it's on the second term. So you can rearrange this as minus x plus p x squared plus y into 1 minus px like this. All right, of which we can factor out a negative x so that we are going to obtain a positive 1. Remember, this is positive 1. So if we factor out negative x like this, this is going to be negative x divided by negative x. Remember, we divide these two, so that is going to give us a positive 1. All right. Px squared divided by negative, that's a positive, divide by a negative, it is going to be negative x squared, and x will cancel, which means we are going to remain with px plus y into 1 minus px. So as you can see already here, we have got 1 minus px, 1 minus px, which is the same. So we are going to factor out, or to take out this common bracket of 1 minus px, meaning to say we are going to remain, we are supposed to remain with a part of minus x plus y like this. But minus x plus y is same as y minus x. So this can be written as y minus x like that. Okay, so this is how we're supposed to factorize in this case. All right, so let's say you wanted to, you expanded actually, because someone could have expanded this bracket, okay, to say that we could have attempted this question this way, px squared minus x, let's say we've got minus x plus y into 1 minus px like this. Then you decide to expand the bracket. So this is going to give us px squared minus x, okay, y is going to expand the bracket, that's y times 1, which is plus y, y times minus px, that's going to be y px like this. All right, so now what you're going to do is you are going to take these terms into 2. All right, we've got 1, 2, 3, 4 terms. So we are going to group these into 2 by grouping so that we factor out what is common between the first 2 brackets. So if you are to consider the first bracket, you're going to say, okay, x is common in this case. Then you factor out your x, which is common. This is going to give us px squared divided by x. That is going to be px. If we divide here, minus x divided by x, x and x will cancel. This will give us a negative 1. So on the other part, you have to ask yourself what is common that you're going to factor out so that you're going to have the same bracket of p minus x. And take note on this part, this is y minus y px, of which it's best for us to write it as y px minus y px plus y. We never changed anything. Just the same, the y, the minus as it is, the positive as it is. What we just need in this case is to have p, because our first bracket here is starting with p, so that we can have p on the first part. So we are going to factor out minus y so that this can be a positive, since px here is a positive. So minus y and minus y will cancel. We remain with a positive px. Y divide by minus y, that is going to give us a negative 1. So as you can see, this bracket and this bracket are the same. So we can factor out that common bracket of px minus 1 we remain here with x minus y. So these two, they are actually the same. It's only the presentation to say it is 1 minus px. Here it's px minus 1. Y minus x, this is x minus y. By these two, they are the same. So you could have factorized in this way or any other way that is applicable. So there are so many ways. Even by grouping, you can rearrange in any way of your choice. All right. So just hopefully that the way that you used is applicable. That is the most important part. All right. So let's check the other part that we have on 1.2. We are now given to determine all the factors of f of x, of the function f of x, if x plus 1 is one of the factors. All right. Whenever you are given the first factor from the given information, like in this case, we are given our f of x, which is equivalent to x cubed plus 8x squared plus 17x plus 10. Then we are given that x plus 1 is a factor. All right. The moment you are given a factor and you are asked to determine other factors or to factor, this is simply to factorize. When you are asked to determine all factors, the question is simply asking you to factorize. So you have the first factor in this case. So what are you going to do? Apply your long division so that you can obtain a quadratic factor. Remember, if you divide a cubic function with a linear function, you're going to obtain a quadratic function. So that means we are going to divide x plus 1 into the whole cubic expression of x cubed plus 8x squared plus 17x plus 10. All right, so let's divide and see what you're going to obtain in this case. So remember, it's always the first term divided to the first term. So x to the exponent of 3 divide by x. This is going to give us x squared. Whatever that you obtain here, we are going to multiply it back to this term. So x squared is going to multiply back. So that's x squared times x, that's x to the exponent of 3, x squared times 1, which is x squared. Then whatever that you're obtaining, we are supposed to subtract in this case. All right, so let's see what you're going to obtain. So if we are to subtract in this case, we are going to obtain x cubed minus x cubed, which is a 0. 8x squared minus x squared, that's 1x squared. So it's 8 minus 1, which is 7x squared. Then the rest of the terms, we are going to drop these terms down. So we have got a plus 17x plus 10. All right, we divide back again, always being the first term to the first term. So 7x squared divide by x. This is going to give us 7x. So we've got plus 7x. We multiply back the 7x to everything, all right? So we are going to obtain 7x times x, which is 7x squared. 7x times 1, which is plus 7x. So we can subtract again, just like what we saw in the previous case. So if you are to subtract here, this is 7x squared minus 7x squared, that's a 0. 17x minus 7x, which is going to give us 10x. Then we can drop the remaining term of plus 10. All right, we divide again the first term to the first term. So 10x divided by x, that's plus 10. We multiply back the 10 to the whole of this bracket. So it's 10 times x, which is going to give us 10x. 10 times 1, which is a plus 10. Then we subtract again. All right, so if we subtract, as you can see here, that's the same part. So we are going to obtain a 0. That means truly x plus 1 was a factor. So what does it mean? It means if this f of x that we are given in this case was being taken from this whole part of x cubed plus 8x squared plus 17x plus 10, with a factor of x plus 1, and we divided with this factor and got this expression of x squared plus 7x plus 10. So it means our f of x is therefore the product of the two, which is the first factor of x plus 1 times the second factor, which is the one that we got after dividing, which is x squared plus 7x plus 10. So that is now we are having a linear and a quadratic. So you have to check, can you factorize this quadratic? If you can factorize, then we have to factorize it. So can we check, is it possible for us to factorize? We have got 1 here, which is the coefficient of x squared. So we focus with 10. Do we have factors of 10 that we are going to add and obtain 7? We have got 5 and 2. So meaning to say we can factorize this. So therefore, our f of x is going to be given as x plus 1, our first factor. Then from our quadratic, we are going to have 2 brackets, x and x. We said the factors is 5 and 2. The one that if you multiply 5 times 2, that's 10. If you add 5 plus 2, that's 7. So we've got plus 5 plus 2 in this case. So we have managed to factorize our f of x completely, or to express it in terms of what? In terms of its full factors. So this is how we were supposed to attempt this question. It was all about your long division. Then you can factorize the remaining part of the quadratic expression. All right, we move on to question 1.3. Simplify each of the following, and we've got 5 marks on that. All right, that is to add, then to subtract, and so forth. Okay, so let's see how we can attempt these typical questions 1.3, 1. All right, so I'm going to rewrite this side so that we can attempt this properly. 1.31. We are given 2 over x minus 3 plus 3 over 2 plus x minus 3x minus 2, everything over x squared minus x minus 6. Okay, so if you are to add or subtract whatever that you're given in this case, make sure that the denominators are in linear form, that is, they are being factorized. So in this case, the first part is okay, the second part is okay, but here we are supposed to factorize in this case, and also rewriting our expressions in a normal way that we understand. Just like this part, it's 2 plus x. It's same as x plus 2. So you can write in a way that you understand properly, starting with the variable, which is x. So it's going to be x plus 2 minus 3x minus 2, everything over. We can factorize here. You can see that the coefficient of x squared is 1. So we are going to just have our normal brackets 2 brackets x and x here, focusing with -6. So we need factors of -6. If we add them, they will give us a -1. So which factors are we referring to? Factors of -6. We have got -3, -2. If we multiply these two, we obtain -6. If we add, we obtain -1. So this is going to be -3 plus 2. All right. So what are we going to do now? We have our fractions, our denominators here being factorized. So we're going to find the LCM of everything, or the LCD, which is, we are referring to the brackets that we have x minus 3. X minus 3 is common. So you're just going to take this one once. So that is going to be x minus 3. X plus 2 is common. So you're just going to take this bracket once. All right. So this is going to be your LCM. So remember the concept, you divide LCM, divide to the denominator of the first part of the fraction here. So x minus 3 and x minus 3, these two, they will cancel out because you are dividing. Take note, it's like this: x minus 3, x plus 2, that's your LCM, divided to x minus 3. So these two cancel, you remain with x plus 2. So that is going to be 2 into the numerator times the bracket of x plus 2. You do the same thing, plus if you are to divide, let's say this time you were dividing this LCM by x plus 2. X plus 2 and x plus 2 cancel, which means this time you remain with x minus 3. So it is going to be 3 into x minus 3. Minus, if we divide our LCM to this bracket, is the same: x minus 3, x minus 3, x plus 2, x plus 2. So this is going to give us a 1 multiplied to the numerator, which is 3x minus 2. Okay, so it's easier for us to start with a number, then followed with an expression, than to start with this expression followed by the number. Either way, you can write it. Okay, from here, we can expand our brackets. 2 is going to multiply everything. 3 is going to multiply everything. The same with -1, it is going to multiply everything. So 2 times x, that's 2x, 2 times 2, which is a 4. Then plus 3 times x, which is plus 3x plus 3 times minus 3, that's -9. -1 times 3, which is negative 3x, negative 1 times a negative 2, which is a plus 2. Okay, don't forget your LCM, that's x minus 3 into x plus 2. All right, from this case, from this part that we have, we can add or subtract all the like terms. We've got 2x, 3x minus x. So this one can cancel here. This 3x minus 3x can cancel, which means you remain with 2x. So this is going to give us 2x. We move on to the whole numbers. We've got this case 4 minus 9 plus 2. So this is going to be 6 minus 9, which is a negative 3, or you can use your calculator direct. That's a negative 3. Everything over your LCM or your LCD. Don't forget to write the LCM throughout until the final answer. So as you can check, we can't divide or cancel anything here. We do not have anything that is common, so you're going to just leave your answer like this. All right, so this was your typical question that you're given. So these are the stages that you're supposed to take to factorize first, then to simplify from there by finding the LCM. If you have the LCM, you can divide back, multiply to the numerator, divide LCM to the denominator. Whatever that you get, you multiply to the numerator and so on. So this is how you can simplify all these typical questions on addition and subtraction. All right, let's check the other part of the question, which is on 1.32, which is having 4 marks on simplifying again. So this is to simplify. All right, so let me just have this question aside. It was having a lot of things, so let me just take it aside so that we can see this one properly. So 1.32, we were given to simplify 3 over a minus 3 over b like this. Everything over 1 over a squared minus 1 over b squared like this. Then times a plus b, everything over 3ab like this. Then you wonder, how am I supposed to simplify? How am I supposed to simplify this? Okay. So that's 4 marks for this. Okay. So in this case, what you're supposed to do is to simplify each part separately. What it means here, guys, if you are to check, this is your numerator, which is a part that you're supposed to subtract. The denominator, again, the part that you're supposed to subtract. But this whole part, it's a division, which means this part was supposed to be written in this way. 3 over a minus 3 over b like this, which is a single part in the numerator. So you can even open a bracket to indicate this is a single part. Divided to, we are having this division. So it's divided to this part of 1 over a squared minus 1 over b squared like this. This is what it means. Everything times a plus b over 3ab like this. So meaning to say we are supposed to have a single fraction here, a single fraction here. All right, then we can simplify. Okay, so let's obtain our single fraction. So remember, from our addition, you find the LCM of a and b, that's ab. Then we divide back ab, divide by a. We are going to remain with b, a, and a cancel. That's b times 3, which is 3b minus AB divided by B, B and B cancels, you remain with A. So this is going to be negative 3A if you multiply. Divided 2, we simplify the LCM of A squared, B squared, that is going to be A squared, B squared. You do the same. That's A squared, B squared divided by A squared. These 2 cancel, you remain with B squared. So it's B squared times 1, which is B squared minus B squared and B squared here will cancel. You remain with A squared. So it's A squared times 1, which is a squared. Everything times a plus b over 3ab. So take note here that you are dividing. So in order for you not to confuse, immediately introduce multiplication, because you now have a fraction and a fraction. So the moment you introduce a multiplication here, you are going to invert the second fraction. So this means we are going to have 3b minus 3a over ab times, the moment you multiply, you invert the second fraction. So it's a squared, b squared, everything over b squared minus a squared. Yes, we know that we are supposed to factorize in this case, but it's easier for you to first introduce your multiplication so that when you are now factorizing, you know that there's no need for inverting anything. You are to simplify only. All right. So that means in this case, we can simplify from this part here. We can factorize so that we can cancel the numerator denominator concept. So the first part 3 is common. So you can factor out 3, which is going to be b minus a over ab times a squared, b squared. There's nothing that we can do. But here we've got b squared minus a squared, which is a concept or difference of 2 squared. Once these are raised to the power of 2, we are going to have b minus a into b plus a from our difference of 2 squares. Whatever that you're obtaining here times a plus b into 3ab. All right. Therefore, we can apply the numerator denominator concept where you can divide as long it is to the numerator and to the denominator. Whatever fraction, as long it's numerator denominator, you can actually divide. So that is the concept that you're going to have. Okay, so let's divide, guys, and see. All right, I can divide 3 here and 3 here. All right, I've got b minus a, b minus a, b plus a plus b are the same. This is same as b plus a. So we can cancel this part here. All right, here we've got ab. This is ab into a squared, b squared. So we are going to remain with ab because there were 2 of them. But here, take note, there's an AB again. So we got AB and this AB, they cancel. So which means we are remaining with nothing in the numerator, just a 1, in the denominator, just a 1. So the whole part was going to give us a 1. All right, so that is how you're supposed to simplify this typical question, guys. I just hope we saw the stages which are very, 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 very necessary in our simplification in this case. All right. Starting from the separation. Yes, you could have simplified, then you invert after that, but we can actually work it in this way, which can be much, much easier. Okay, so let's just hope everything was clear on question number 1. So for you to obtain this whole 16 marks. All right, question number 2. Simplify the following expressions. All right, we are given to simplify the following expressions in this case. All right, so the first part, let's just have this one also aside so that we can see it properly. All right, so this was question 2.1. We are asked to simplify x to the exponent of -2 plus x squared minus 2, everything over 1 plus x, like this. So this was 1 plus x times x to the exponent of -1, everything to the exponent of -2, +2, like this. All right, so this is what we're given exactly, x to the exponent of -1, then the whole part to the exponent of 2. All right, so this is what we have, guys. 5 marks for this. All right, let's see why 5 marks. Okay, anyways, if we are to check here, there was a tricky part that was just happening to say that. Okay, let's start by expanding so that we'll talk about that tricky part later on. All right, if we are to check in the denominator here, we've got an exponent of 2, which can be raised in this bracket. Remember from our laws of exponents that if I am given, let's say this is x to the xy, like this, to the exponent of n, this can be written as x to the exponent of n, y to the exponent of n. Each part is raised to the exponent of n. So in this case, we've got this condition of 2, which can be raised to this bracket and to x to the exponent of a -1. Okay, so the numerator for now, let's just leave it like that. X to the exponent of -2 plus x squared minus 2, everything over. If we raise this to the exponent of 2, this is same as to the exponent of 1. So we're just going to multiply 1 times 2, which is 2. So it is going to be 1 plus x to the exponent of 2. Minus 1 times 2, which is x to the exponent of -2. All right. So in this case, we have something that is unusual in our simplification. What is this part? The x to the exponent of -2 is very, very unusual in our simplification. All right, what if we are to factor it out? Because we have it in the numerator, we have it in the denominator. So what if we are to factor out the x to the exponent of -2 in the numerator, so that we can cancel with this one in the denominator, because we are not used to this. So let us cancel it out. But you can't just cancel to say, okay, this is x to the exponent of -2. This is x. Let me cancel. Like, no, it's impossible, because here it's an expression that you are dealing with. So you're supposed to factorize. So we can factor out, in this case, x to the exponent of -2 in the numerator. Remember, when you factor out, what does it mean? You are going to divide x to the exponent of -2 divide by x to the exponent of -2. That's a positive one, because these are the same. They will just cancel. If we move to x to the exponent of 2, it's like this: x to the exponent of 2 divided to x to the exponent of -2. We are dividing. So what are we going to do? We are going to subtract the exponents, because the bases are the same. So it's 2 minus -2 like this, which is 2 plus 2, which is x to the exponent of 4. So this is going to give us plus x to the exponent of 4. Minus 2 divided to x to the exponent of 2 is like this. It's 2 over x to the exponent of -. So we are simply writing this on top, which is 2x to the exponent of 2. So it's minus 2x to the exponent of 2 from our laws of exponents. Okay, everything over 1 plus x squared x to the exponent of -2 like this, whereby we can now divide, so that we'll work with a remaining expression, because these two is a multiplication. So we can divide these two out. We no longer have the x to the exponent of -2. So which means we are just remaining with a normal expression in the numerator, which we can rearrange as x to the exponent of 4 minus 2x to the exponent of 2 plus a 1. Everything over 1 plus x to the exponent of what? To the exponent of 2. All right. Which means in the numerator, we can simplify, we can factorize. Remember, this is a disguised quadratic expression. Why am I saying it's a disguise? Okay, I want us to check this part. If we are to write x to the exponent of 4 minus 2x to the exponent of 2 plus 1 like this, if we are to change it to a normal way that we are used to, where we can say let, in this case, we can say let k be equal to x to the exponent of 2. Meaning to say the x to the exponent of 4 can be written as x to the exponent of 2 to the exponent of 2. Minus 2x to the exponent of 2 plus 1. This whole part, we are now having x squared. So this x squared is now represented by k. So meaning to say, in place of x squared, I'm going to write this as k. So this is going to be k squared. We have got k squared minus 2k. Remember, x squared is represented by k. So this is going to be 2k plus 1. We are now having a normal quadratic expression that we are used to, where we can factorize this. So factorizing, we have got here the factor that we are going to focus with is 1. We are focusing with the constant of 1. So meaning to say we are going to have k in this bracket, k in this bracket. Factors of 1, that when you add, you obtain -2. That's -1 and -1. So we're going to have -1, -1. But remember that we are factorizing for x, not for k. So x, now we are going back where we introduced k, where we said k is representing x squared. So in place of k, we are going to replace our x squared. So this was going to be x squared minus 1. In place of k, x squared minus 1. So that means after this part has been factorized, we are obtaining x squared minus 1 into x squared minus 1. Everything over 1 plus x squared. All right. X squared minus 1. What can we do in this part? This is a difference of two squares because 1 is a perfect square, which can be written as 1 squared, 1 squared. So meaning to say we can factorize this. Remember from our difference of two squares concept, this is going to be x minus 1, x and 1, and the other bracket is going to add x plus 1. So this is the difference of two squares for this first bracket. We move on to the second bracket. It's a difference of two squares again. We're meaning to say we are going to have x minus 1 into x plus 1. Everything over our denominator, which is 1 plus x squared, which is same as 1 plus x into 1 plus x. We've got two brackets. It's a squared, meaning to say there are two brackets. So 1 plus x can cancel with 1 plus x. 1 plus x can cancel with 1 plus x. X plus 1 is same as 1 plus x. So these two can cancel. We are going to remain with x minus 1 times x minus 1, which is same as x minus 1 squared, or x minus 1 into x minus 1. All right, so this is what we're supposed to obtain from your simplification. Guys, as you can see, it was a lot. It was a lot here. You're supposed to know your laws and applications, your exponential laws, and so forth, and so forth, and so forth. I just hope we are going to have these typical questions as much in our revisions as we prepare for exams. For those ones who are writing in August, as time permits us, we are going to have more revisions together. All right, on question 2.2, we are now given now to simplify, okay? In fact, show that. It's not to simplify, to show that. Okay, we are asked to show that b is equal to a to the exponent of 3 from these logarithms. Let's hope it's going to be clear if I write it here. Okay, we are given here 2.2. The logarithm of 3 in base of a, which is equal to the logarithm of 27 in base of b. Okay, and we are supposed to show that here b is equal to a to the exponent of 3. Okay. If you are to check here, guys, we understand that if the bases are the same, we can work out something. We can simplify our logarithms in a better way. But here we can't even change these bases to be the same. A and B, these two letters cannot be related. So, but there is something about the 3 and the 27 which can be common here. We have the 3, the 20, which can be common. Remember, 27 can be written as 3 to the power of 3. So meaning we can write this as, I want you to see something, the logarithm of 3 in base of a equal to the logarithm of 3 to the exponent of 3 in base of b. At least we have got the 3 concept here. Okay, from our laws of logarithms, remember, if we are given an exponent, if we have got an exponent p log of m, this is going to give us log m to the exponent of p. We raise this to be an exponent. So if we are given it as an exponent, we can drop this to multiply the log. So we can drop this number to multiply our log. So it is going to be log 3 base a is equal to 3 log 3 in base of b. Okay, now that we have the 3 here, the 3, and the 3 here, how can we change now to the same base so that it can be base 3? Because here we have got 3, here we've got 3. How can we change so that 3 can be a base? There is this law that you're supposed to understand. The logarithm of a in base of b can be given as 1 over the logarithm of b in base of a. This allows us to interchange the number and the base. B was a base, it's now a number. A was a normal number, now it's a base. So the moment I introduce 1 over on this log, I can interchange. So what does it mean? If I introduce 1 over both sides, this is going to be 1 over the logarithm. The moment I introduce 1 over, I interchange these numbers now, the 3 and the a. So this is going to be log A base 3. All right, which is equal to, if I introduce 1 over, this 3 is going to remain as it is. So this is 3 is going to multiply 1 over. We are introducing 1 over on the log, not on this 3, but on the log. So it is going to be 1 over. The moment I introduce log, these two numbers, they interchange. So this is going to be the logarithm of B now in base of 3. So as we can see, we now have the concept of the log base. Okay, let me just write this one properly. So this is now log B in base of 3 like this. All right. So as we can see, we now have the concept of log a certain number, base 3, log a certain base 3. So the base is now the same, which at least can give us some hope that where we are going, we can simplify because the bases are the same. Okay. I want us to see something. Let us cross multiply so that we can remove our fractions because we are now dealing with fractions. So if you cross multiply here, this is going to be log to this side, log B base 3 times 1, which is log B base 3 is equal to 3 times log A. So it is going to be 3 log A in base of 3 like this. We are multiplied to 3 and the log by cross multiply. Okay. We are to find a concept that B is supposed to be equal to A to the exponent of 3. We have got a B, we have got an A here. From this law that we talked about before, we said P log M is same as log M to the power of P, where a number that is multiplying a log can be raised to be an exponent, which is what we can do to these 3. We can raise these 3 to be an exponent of the logarithm. So this is going to give us the logarithm of B in base of 3, which is equal to the logarithm of, if we raise the 3 to the exponent, it is going to be A to the exponent of 3 in base of 3. Now there is this concept in our logarithm that we are supposed to know under our logarithm, that the logarithm of a number in a certain base, if it is equal to the logarithm of a certain number in the same base, referring to the base of B like this, log of base B, log of base B like this, it automatically means that A is equal to C. So therefore, A is equivalent to C. So if we can apply this concept, because we have got the log of base 3 here, we have got the log of base 3 here. So automatically it means therefore our B is equal to A to the exponent of 3. So that is what we are supposed to show in this case, show that B is equal to A to the exponent of 3. All right, so it was another type of equation. Yes, it needed us to apply our laws of logarithms, to play around our laws of logarithms and so forth and so forth. Okay, but this is how you're supposed to attempt this typical question. Okay, 2.3. Let's check what we are given on question 2.3. We are now given solve for x. Okay, if we are given this one, all right. So solve for x. So that's 2.3. We are given the square root of 3x minus 5 minus x, which is equal to minus 5. Take note, the minus x is out of the square root. Okay, so before you square, take note, you are supposed to have the part that is under the square root as a single term before you square. So you can transpose first the minus x with this one, which is outside of the square root, to the right hand side of the equation, so it can be a positive. So this is going to be equal to x minus 5. Now you have a single term or a single square root. That's where you can square both sides to remove the square root. So the moment you square both sides, this remains as 3x minus 5. Remember, square root and a square, you are removing the square root. And on this part, you are going to square. But knowing or having this concept, guys, you are supposed to know that if you're expanding a minus b squared, this is going to give us a squared minus 2ab plus b squared. So this means that if we are to expand this, this is your a, this is your b. So it's going to be x squared, that's b a squared, minus 2ab, that's minus 2 times your a, which is x, times your b, which is a 5. So this is going to give us negative 10x. That's minus 2ab. So it's minus 10x in this case. Then b squared, which is the 5 squared. So 5 squared, which is a plus 25. Take note, it's plus b squared. So you follow this concept, or you can expand these brackets separately. Still it's one and the same. So these two, they are equal. So I can start with my quadratic expression, x squared minus 10x plus 25, which is equal to 3x minus 5, so that I can transpose my terms to the other side of the equation. 3x is going to be a negative, so it's going to be x squared minus 10x minus 3x. If we transpose, minus 5 is going to be a positive, so it is going to be 25 plus 5, which is equal to 0. So x squared minus 10 minus 3, that's minus 13x, 25 plus 5, which is a 20. That is a 30, sorry, that's a 30 here, which is going to give us a 0. Okay. So we are having x squared minus 13x plus 30, which is equivalent to 0. So you can factorize so that we can solve for x, or you can apply any method to solve this equation. But here we can apply our factorization. The coefficient of x squared is 1, so we can easily have our two brackets. Focus with positive 30 here, which is our constant term. What are the factors of 30? But if we add, we must obtain negative 13 factors of 30. But if we add, we obtain negative 13. So for you to have these factors, it's a trial and error concept. All right. But in this case, we've got negative 10 and negative 3. Negative 10 times negative 3, that's positive 30. If we add negative 10 plus negative 3, that's negative 13. So these are the factors, negative 10 and negative 3. So each bracket is equal to 0. So therefore, x is going to give us 10, or x is going to give us a 3. But before you conclude, make sure that you test the values. Do not underline these values to say these are the answers. Test your values and see if they are giving you the exact thing. If x is equal to 10, you substitute here 10, you substitute here 10, and see if you are going to obtain a negative 5. So in this case, if we tested our values, the exact value was going to be at 10. X cannot be equal to 3. So I want you to test and see these values that you're given. All right, so these were the that is how you're supposed to solve for x. In this case, that was question 2.3, having a total of 4 marks, and everything on question 2, 14 marks. Okay, that's a lot. All right, let's move on to question 3. We are given to make A the subject of the formula from the given equation, or this formula that we have in this case. All right, so how can we make A the subject in this case? We are given 3.1. A is equivalent to 10e to the exponent of 0,2 A. And take note, the A to be the subject is the small letter a. So this is the one that you're supposed to make the subject. All right. So how can we make it the subject, guys? Okay. There are so many ways that you can attempt this one in this case, but you choose which one is best. Okay. As for me, I was just going to divide by 10 both sides so that we can have E separately here. So you can divide by 10 by 10. So this can cancel. A over 10 is equivalent to e to the exponent of. So which means I can even start with the e on this side. E to the exponent of 0,2a is equal to a over 10. All right. Since I have e, it's best for me to introduce ln, not a normal log, but to introduce ln. Why introducing ln? Because we know that the ln of e is equal to 1. So we can introduce ln both sides in this case. So this is going to be the ln of this expression e to the exponent of 0,2a, which is equal to, introduce ln. This is going to be ln a over 10 in this case. So take note, by introducing ln, I am supposed to apply the laws of logarithms, where we understand that from what we talked about before, we said if it is p log m, is same as log m to the power of p. Ln and log is the same. which means if there is an exponent, you are supposed to drop that exponent to multiply the log, just like 0,2a, it's an exponent, so you can multiply the ln. So this is going to be 0,2a, the ln of e, which is equal to the ln of a over 10 in this case. All right. How can we make a the subject? Okay, in this case, we said ln e is equal to 1. So meaning to say here, we are just going to remain with 0,2a, which is equal to ln a over 10. So we can divide by 0,2 both sides, by 0,2 both sides. So that means a is equivalent to this whole part, of which we know that 0,2, if we divide here, 1 divide by 0,2, that's a 5. So this is going to give us 5 ln a over 10 like this. Okay, of which someone can even apply the laws of logarithms to say if you are dividing a number like this, it means we were subtracting the log. So it was ln 5 in this case like this, ln of a minus ln of 10. You can even write it this way if you want, but a is already subject. You can even leave it like that. Okay, so this is how we're supposed to attempt this typical question to make a, the small letter a, the subject, introducing of ln, and knowing that the ln of e is equal to 1 was very, very important. All right. 3.2, we are now given that there is a container that is filled with red, white, blue marbles in the ratio of 1:2:5. The total number of marbles inside the container is 104. How many marbles of each color are inside the container? Take note here, guys. We are given a ratio which shows us how these marbles, they were being distributed, or they are being given in the ratio of 1:2:5, which follows this concept of red to white to blue. So from this ratio, we can have our total ratio in this case, which is the total of 1 + 2 + 5, which is 8. Then we have got the total number of marbles that we have in the container. That is our total marbles. In this case is 104. So how can we determine the ones which are red? We are just going to use our ratio direct. So the red, it's according to its ratio, it's 1. So it's 1 over the total of the ratio, which is 8, times the total of marbles that we have, which is 104. So this is going to give us the total number of red marbles, which is 13 red marbles. Okay, so we move on to the white and so on. So for white, we are going to do the same thing. According to our ratio, white is 2. So it's 2 over the total ratio of 8 times 104. And this is going to give us 26. So we've got 26 white marbles in this case. We move on to the blue. So blue, according to its ratio in this case, it's having a 5. So that's 5 over the total ratio of 8 times 104. So this is going to give us a total of 65 blue marbles in this case. Okay, so to verify your answer, if you add 13 plus 26 plus 65, you must obtain a total of 104 marbles. That is the number of marbles in the container. All right, so that is how we're supposed to attempt this typical question. 6 marks for that. All right, question number 4. Consider fig 1, which shows point P, point Q, point R as vertices of triangle PQR. Okay, so this is our triangle PQR, and we're given its vertices. All right, so this is our triangle. We're given these points and so forth and so forth. All right, so from the triangle that we are given, we are now asked to show that the line PQ is perpendicular to line QR. Okay, there are 2 lines that we are given, and we are asked to show that these 2 lines, they are perpendicular, which is line PQ and line PR. Okay, there's something that is happening here. There's another question that I left. Oh, it's here. Okay, it's here. All right, let's just hope it's gonna be fine. We'll check that one out. Question 3.3. Okay, we are asked to solve for x on 3.3. We almost left this question out. Okay, anyways, let's check. Okay, it was actually having a lot of things also. I can just try to have it here. All right, so this is 3.3. So on this question, we are given 4 over the total we are asked to solve here, 4 over x minus 2, which is equivalent to 4x plus 8 over the total of x squared minus x minus 2, plus 4 over x squared plus 4x plus 3, like this. Okay, so if you are asked to add or to solve for x, we have got two fractions in this case that we are supposed to add on the right hand side, because these whole fractions we've got 1, 2, 3. So we can't cross multiply direct in this case. So what we can do at least is to express it as a single fraction. We can work it from there. Okay, so let's see. 4 over x minus 2, there's nothing that we can do so far, but on the right hand side we can try to combine 4x plus 8. Then we can factorize our denominators. In this case, the coefficient of x squared, which is 1. So we can have our two brackets of x and x here. Factors of -2, that when we add is going to give us -1. So we need factors of -2. When we add, we obtain -1. So that's -2 and a +1, which is going to give us a -1. So we've got -2, +1, plus 4 over, we do the same, we factorize this part, or also x and x, since the coefficient of x squared here is a 1. We focus with our constant 3, factors of 3, if we add, we obtain 4. That's factors of 3, we've got 3 and 1. 3 times 1, that's 3, 3 plus 1, that's 4. So it is going to be x plus 3, x plus 1 in this case. All right. So from this concept that we are given, we can express as a single fraction this part by combining our fraction. Okay, so remember, for us to combine, we are supposed to find the LCM or the LCD of the two. So it's going to be 4 over x minus 2 in this case. Or someone can even at this stage introduce multiplication to multiply each and every term separately. You can do that, to multiply by the LCM each and every part, multiply by the LCM each and every part. I think that can be much easier to explain that way. Okay, let me show you. So this part, you can multiply the LCM. In this case, we are having x minus 2, x minus 2, x plus 1. All right, so we are going to have our LCM, which is, or let me write it aside so that it can help us by just inserting. So our LCM in this case is going to be x minus 2. We've got x minus 2. It's common, so we just take it once. X plus 1, x plus 1. So we've got x plus 1. X plus 3. Okay, it's just appearing once. We take it x plus 3. So this is going to be our LCM. Remember how to determine your LCM. So this is the one that you're going to multiply throughout your terms. Okay, so this one we are going to multiply by LCM, x minus 2 into x plus 1 into x plus 3. We do the same here. We multiply by our LCM, which is x minus 2 into x plus 1 into x plus 3. We do the same here. We multiply by the LCM, x minus 2, x plus 1 into x plus 3. So this will help us now, so that this we can cancel x minus 2, x minus 2. We remain with these two brackets and 4. So it is going to be 4 into x plus 1 into x plus 3, which is equal to, we do the same here, x minus 2 and x minus 2 cancel, x plus 1 will cancel, meaning to say we are remaining with the 4x plus 8 into the bracket of x plus 3, which is remaining. Plus, we do the same thing here, x plus 3 and x plus 3 will cancel, x plus 1 will cancel, meaning to say we are going to remain with the 4 and the bracket of x minus 2. All right, so as we can see, it's going to give us a simplified part now that we can expand our brackets, simplify together. That's what we can actually do. All right, so let's expand and see. Okay, let's expand and see. Okay, do we have anything common now? We do not have. Now we do not have here. All right, so let's expand. It's going to be 4 into x, which is 4x. So this is same as 4x, 4 times 1, which is 4. So we are going to expand by 4x plus 4. So let's expand 4x times 4. That is going to be 4x, sorry, times x, which is 4x squared. 4x times 3, that is 12x. We move on to 4, so it's 4 times x, which is 4x. 4 times 3, which is a positive 12. Okay, this is equal to, on the other side of we do the same, just like previous part. 4x is going to multiply this and everything. Okay, so it's 4x times x, which is 4x squared. 4x times 3, which is 12x. 8. Now we move on to 8. So it's 8 times x. That's 8x. 8 times 3, which is positive 24. All right. This one is direct. Plus 4 times x, which is plus 4x, plus 4 times negative 2, which is a negative 8. All right. So what you can do is you can simplify your terms, but some of the terms you can even cancel by just looking. As long a term is the same from the left-hand side and on the right-hand side, like 4x squared. If you transpose, these two cancel, 4x squared and 4x squared, if you transpose. The same thing with 12x and 12x, these two cancel. So some of the terms you can even cancel them, say, okay, these, even whatever that is going to happen, these terms, they are definitely going to cancel. Or you can even leave the 12x since we have got other terms, or you can cancel it, no problem. All right, so in this case, we are going to remain with here 4x plus 12 is equal to, let's see, here we've got 8x and 8x, which is 12x. So this is going to give us 12x minus 8 minus 24 minus 8, which is going to be 16. So that will be a 16. So if we transpose, that will be 12 minus 16 is equal to 12x. 4x to the other side is going to be a negative 4x. So 12 minus 16, which is negative 4, is equal to 12x minus 4x, which is going to be 8x. So you can divide by 8 by 8. So our x is going to be negative 4 over 8, which is a negative half in this case. Okay, so there are so many ways that we could have used. So as we are revising, I just hope we'll come again and have other methods of solving these typical equations. Like I said, you could have simplified this as a single fraction, then you can cross multiply after that, or you can do this way. Okay, so like, there are so many ways, so many ways. We'll see as time goes on, how are we supposed to apply those typical methods or ways. Okay, now the question 4, we are given to consider this fig. I think we wrote about, we talked about this information. So the question on 4.1 was to show that line PQ is perpendicular to QR. Okay, for two lines to be perpendicular, so this is 4.1. For two lines to be perpendicular, PQ and PR, if we are saying PQ is perpendicular to QR, it means the gradient of line PQ is the to the gradient of line QR should give us a -1 if we are to multiply these two. The product of the gradients is supposed to give us a -1. So this is how you can prove that these two lines are actually perpendicular to each other. So that means we are supposed to calculate the gradient of PQ, then we calculate the gradient of QR, knowing that the gradient is simply the change in Y over the change in X, which is Y1, Y2 minus Y1 over X2 minus X1. Okay, so let's start with the gradient of PQ. All right, that's P to Q. So P to Q. So this is our first point. This is our second point. So Y2, that's a -1 minus Y1, which is a -3. So negative 3 over x2, which is 1. So this is 1 minus x1, which is a negative 1. Okay, so if we are to simplify this, we are going to obtain a positive 1. So this is the gradient of PQ. We move on, we calculate the gradient of QR. So the gradient of Q to R. So this is Q, this is R this time. Q is our first point and R is our second point. So meaning to say y2 minus y1, that's our y2, which is 5 minus 1. So it's 5 minus 1 over x2, which is minus 5. So it's minus 5 minus x1, which is a 1. So this is going to give us a negative 1 from our calculator. All right, so let's see what are we having in this case. So the gradient of line PQ in this case is a 1. So the gradient of line PQ times the gradient of QR, we want to prove, is it truly giving us a negative 1? So the gradient of PQ, that's 1, times the gradient of QR, which is negative 1. So this is going to give us a negative 1. So therefore, the two lines are perpendicular. So therefore, PQ is perpendicular to line QR. All right, so that is what you're given. In this case, in order for you to prove, it's all about the gradient. The product of the two gradients should give us a negative 1. Okay, determine the size of theta, the angle of inclination between line QR and the x-axis 2 marks. Okay, the angle of inclination of this QR, which is theta. So remember, the angle of inclination is the angle that is determined from the gradient. Remember that tan of theta gives us the gradient in this case. All right, so we are talking about the line QR, and we calculated the gradient of QR here. We got a negative 1. So the negative part means that our answer is an obtuse. This angle is an obtuse angle. All right, so this is 4.21. Remember that tan of theta is equal to the gradient. So to find the theta, it means that theta is equivalent to arctan, the gradient. All right, so in this case, we are referring to the gradient of the line that is between the x-axis, which is QR in this case. That is this line QR, and we have its gradient of QR, which is negative 1. So meaning to say, we are going to obtain arctan of negative 1, which is negative 45 degrees. So the negative is to show you that the quadrant that you're talking about, it's not for tan, it's for sine, the second quadrant. So that's why we're having a negative. So to find the actual angle theta, we are going to subtract from 180. This 45 degrees, which is a negative, is this angle here. This is where we have our 45. This acute angle here, this is your 45 degrees. So to find this whole angle theta, it is going to be 180 of a straight line minus the 45. You subtract the 45 degrees from 180. And also you must know that in the second quadrant, it's 180 minus the reference angle, which is 45 degrees. So that means our theta, which is going to be 135 degrees, the angle of what? Inclination. All right, so that was it, 4.21. 4.22, the coordinates of midpoint of QR. All right, the midpoint of QR. So we have got our Q here and we've got our R here. So remember that the midpoint, we can simply take it from our formula. All right, so let's just have our midpoint here. All right, sorry for that. Sorry for this one. Let me adjust. So we need the midpoint of QR in this case. That is from Q to R, and M being the midpoint, we are going to add x1 plus x2 over 2. Then we add y1 plus y2 over 2 in this case. So that means the midpoint referring to the point Q and the point R. In this case, we are going to add 1 plus minus 5. So it's 1 plus minus 5 over 2. So this is for x. We move on to y. That's minus 1 plus a positive 5, minus 1 plus a positive 5, everything over a 2. So this is going to give us m. So m is going to be negative 2 if we simplify this direct from our calculator. All right, so from there, we are now given 4.22 to calculate the coordinates. All right, this is the one that we calculated. 4.23, the equation of line QR, leaving your answer in a gradient intercept form, the gradient of QR. Okay, QR, if you are to check here, we have its gradient. This is our QR in this case, and we calculated the gradient of QR here. The gradient of QR, it was a -1. So remember that we are asked to give this in a gradient intercept form, where we know that the gradient intercept form, it's a format where you can write in the form of y is equal to mx plus c, where m is representing the gradient of the line, and we have the gradient of line QR. We calculated here the gradient of QR, which is a -1. So we are just going to substitute our gradient of -1, the one that we calculated before. Sorry for that. So this is going to be -1x, which is -x plus c. What does C represent? C is the y-intercept, which is the value that you can determine by substituting any of the points which lie on line QR. This is our line QR here. So you can substitute any of the points. You can substitute R, you can substitute Q, but the importance of this question, or the advantage of this question, was that this line, it passes through the origin, and we know that is your y-intercept, where it is equal to 0. So the y-intercept, if it passes through the origin, is at what? Is at 0. So meaning to say, we can write this equation as, therefore, y is equivalent to -x plus 0, which is y is equal to -x. All right, so this is how you could have obtained your equation, or you could have substituted. Let's say you didn't see this, that it's passing through the origin, then you can substitute any point of your choice. In this case, we were given points like point 1 minus 1. So we can work with point Q. Remember, point Q is 1 minus 1, where you are given x and y. So y is -1 when x is equal to 1. So this is going to be -1 plus c. So if we transpose -1, it's going to be -1 plus 1, which is equal to c. So c is a 0. As you can see, we are obtaining the same c by substituting any of the given points, or you could have taken that one direct from what? Direct from the graph, or from the Cartesian plane that you are given. All right. So that was our question 4.23. Let's check the other part of the question, which is 4.24. All right. Now we are given the equation of the line on 4.24 to determine the equation of the line passing through point R, which is parallel to PQ, leaving your answer in the gradient intercept form. So take note here, it is parallel to PQ, passes through the point R. Okay, let's start by having our point R, okay? This is our R here. The line is supposed to pass through this point R and parallel to PQ. Okay, this is our R, which is -5, 5. Okay, so we have a point R in this case, 4.24. So our point R is -5, 5. All right. Then the line that we are going to have, which passes through this point, it is parallel to PQ. What does it mean? For parallel lines, it means the gradient of this line, which is going to pass through R, is equal to the gradient of line PQ. That is what it means. Do we have the gradient of PQ? Yes, we calculated this gradient of PQ before on the first part here. When we are asked to show that these are perpendicular, we saw that the gradient of PQ is equal to 1. So this is going to be a 1 in this case, meaning to say the gradient of this line that we are supposed to determine its equation is a 1. Once you have the gradient and a point, it's enough for you to have an equation using which concept? Y is equivalent to mx plus c. That is the gradient intercept form. So y is equal to m, which is your gradient, which is 1. So this is 1x plus c, of which 1x is same as x. There is nothing that we can just leave it like that. So now we need to find the value of c. This time the point we are given, so we're supposed to substitute the value of x and the value of y. To say at this point that the line is passing through R, at that point y is equal to 5. While list the value of x at that point, it's a -5. So you substitute x here, which is a -5 plus c. So now we can determine the value of c by transposing -5. This is going to be 5 plus 5. So meaning to say our c is going to be equal to 10. So therefore, the line is given by the equation y is equal to x plus c, where c is equal to 10. So this is going to be x plus 10. So that is how we're supposed to attempt this typical question. Yes, it was a little bit challenging. You're supposed to at least apply the basic part that we have, the knowledge of straight lines, the issue of gradients, and so forth. Okay, so that was our question 4. Question 5, we are given the sketch. In Fig 2, it shows the graphs of y is equal to k over x with the domain from -infinity up to 0. The line of y is equal to mx plus c with the domain, which is all the real terms that we have. The graphs intersect at point A, which is at this point, and -1, 4. So this is the point of intersection of the two graphs. They intersect at the point A and at the point -1, 4. Okay, E -1, -5, 0 is the point on a straight line. This one, -5, 0, which means that is our x intercept. As you can see, this is our x-axis here according to our graph. So take note, this is your x-axis. This is your y-axis. So we know that in the x-axis, y is equal to 0. So that is our x-intercept in this case. In our y-axis, we know that x is equal to 0. All right. So in this case, we have got two functions. This function here of k over x and a straight line and so forth. So how can we, okay, let's see. The first part of the question on 5.11, we were given to show that the values of k, m, and c respectively for -1 and -5. Okay, let's see. How can we show that k is 4, m is -1, c is -5? Where is k? K is given from the function here of k over x. This is where we have our k. All right. So if we are to take note on our k, we are given this function as y is equal to k over x. So we can find the value of k by substituting any point as long it lies on the function, which is we have got a point here of -1, -4. It's a point of intersection. It means it lies on both functions. So we can take this point where we are given the value of x, which is -1, the value of y, which is -4. So y in this case is -4 when our x at that point is a -1. So this can help us to find the value of k. Cross multiply, that's 1 times k, k is equal to -1 times 4, which is a +4. So k is equal to 4. All right, we move on to another one, which is m. M, where is m? M is found on a straight line where we are given y is equal to mx plus c. So the m here, it represents the gradient of the straight line. If you understand this, you won't have a challenge. So m is simply representing the gradient, meaning to say we are going to take this gradient from the points that we are given on a straight line. Our straight line passes, on this straight line, there are 2 points. Point E is on a straight line. Point -1, 4 is also on a straight line. So to find m, we can use these 2 points, which is point E -5, 0. So you can use point E, which is -5, 0, and the point of -1, -4, which is the point of intersection. These two can help us to determine m, which is the gradient. So remember that gradient is the change in y over the change in x, which is x2 minus x1. So this is your first point, second point. So y2, that's -4 minus y1, which is a 0 over x2, which is -1 over minus x1, which is -5. All right, so this is going to give us m, which is -1, our gradient. All right, so that is how we could have calculated m in this case. All right, then we move on to C. C is representing the y-intercept or the value of C on the equation. So you can determine the value of C by finding the equation of the line. If you are to determine the equation, because we have got C here, so remember that y is equal to mx plus c, and we got that m, it's -1. So you can determine the equation of this line. So it's -x plus c. So to find the C, we can substitute any point as long it's on the line. We can substitute point E or -1, -4, any point. So here I'm going to substitute point E, which is -5, 0. We have got xy here, and our y is at 0, while x is -5. So this is -x, meaning to say we've got minus, substitute x, which is -5 like this. So that is minus, which is a positive. So if we transpose 5 to this side, it is going to be 0 minus 5 is equal to C. So C is equal to -5. All right, so these are the values that we're supposed to determine: the value of M, the value of C, the value of K. So C here, that's -5. All right, determine the coordinates of A. Where do we have the point A? The point A, the point A. Okay, the point A here, it's a point of intersection. Remember, we are given that A is a point of intersection and another point of intersection. So for you to determine the point of intersection, you have to solve the given equations simultaneously for the given functions. Remember, at a point of intersection, the two functions, they are equal at a point of intersection. All right, so this is 5. Okay, we can even just try to work it here, down here. So this is 5.12. So to find the point of intersection of a curve and a straight line, we simply have to solve the equations simultaneously. So the first one, it was y is equal to k over x. Now we have the value of k, which is 4. So it's 4 over x. And also the straight line of y is equal to mx plus c. We have the value of m, which is -1. So it's minus x. We have the value of c, which is -5. So at the point of intersection of these two graphs that we see, these are the two graphs that we are given. The point of intersection, we simply solve these two equations simultaneously because we are saying they are equal at a point of intersection. So that means in this case, we are saying 4 over x in this case is equivalent to -x minus 5. Since y and y are equal, so you can solve for x. Cross multiply to remove the fraction. In this case, that is going to be 1 times 4, which is 4, is equal to x times -x, that's -x squared. X times -5, that's -5x. So we can solve this transpose to the other part, which is going to be x squared minus 5x is going to be plus 5x plus 4, which is equal to 0. So as you can see, we're now having a normal quadratic equation, which we can solve by factorization. You're having two brackets equal to 0 here. We've got x and x. Focus with factors of 4. So factors of 4, that when you add, you obtain a +5. That's 4 and 1. 4 times 1, that's 4. 4 plus 1, that's 5. So this is going to be +4 plus 1 is equal to 0, meaning to say we are having the values of x now. X is equal to -4 or x is equal to -1. All right, so these were the two possible values of x. But as we can see, one of the point of intersection is already indicated on the graph here. We are having this point of intersection here at x is equal to -1. So meaning to say A is going to be the other part, because we have these on our answers here. We can see that there is an x which is equal to -1. This is representing already the point of intersection, which is already there. So the x that we are remaining with is this one of -4. So we are going to use x is equal to -4 at this point A. So at point A, x is -4. What about the value of y? Because a point is supposed to be written as x1. Remember, we said at a point of intersection, the two functions, they are equal. So we can substitute x which is minus 4, into any of these two equations because they are equal at a point of intersection. So when x is equal to minus 4, I can substitute here. Y is equal to 4 over x, which is minus 4. So y is equal to minus 1. I can substitute here. Y is equal to minus x. Our x is minus 4. So it is going to be minus 4 minus 5. Minus, minus, that's a plus. So 4 minus 5, which is minus 1. So you can see that y is minus 1 at that point. So you can substitute any point of your into any equation of your choice. So y is negative 1. So this is our point A, which is going to be negative 1, negative 4, negative 1. All right, so that is how you determine the point of intersection. You solve the given equations simultaneously. All right, so let's check the other part of the question. Let's see. Now we are given to determine, all right. We are given that determine the length of BC. Okay, take note, the length of BC if OD is 6 units and BCD is perpendicular to the x-axis. Okay, the length of BC, let's see what we have. The length of BC. All right, so the question is asking us to calculate the length from this point B to this point C. Okay, I want you to take note of something here. Given that OD is 6 units and BCD is perpendicular, okay, which means BCD, this one, it's a straight line, it's a perpendicular, like it's a just a vertical line, so you can just subtract our points from one point to another. Okay, but the most important part is that we are given that OD is 6 units. Okay, from O to D. Let's check, where do we have our O? This is where we have our O here. From this point O, which is our origin, to this point D, it's 6 units. Meaning to say, we are, remember, this is y-axis, x-axis. So on this side, we are on the positive side, negative. So if it is 6 units, it means directly at point D, we are at -6 at point D here. We are at -6. So if we are at -6 in terms of x, because this is a value for x, in order for you to determine the distance from this point, which is BC, since it is a vertical line, you can subtract the value of y. Let's say this is your y1, this is your y2 at point B. We can subtract the distance to find the BC, just y2 minus y1, or you can use distance formula because you know that x is equal to -6, so you can have points at this point, at this stage. So what is needed is to find the value of y at point B, the value of y at point C. So how are we going to do this? Okay, remember guys, B, it's a point which is on this line. This is where we have our B. Take note where our B is. It lies on the straight line. So meaning to say, we can substitute into the straight line. Y is, remember, we got the equation of a straight line. We said this is now given as y is equivalent to -x minus 5. All right, that was -x minus 5 in this case. All right. So at the point of -6, at this point -6, what is the value of y? Because we are saying the point B, it lies on the straight line where x is -6. So it is going to be -6 minus 5, which is going to be +6. So this is going to give us a +6 in this case. Sorry for that. So y is going to be +6 minus 5, which is 1. So it means at this point B, the value of y is a 1. Or we are saying the point B is given as x is -6, y, which is 1. We can write it as a point. At point C, this point, it lies not on a line, but now it lies on the function of f, which is y is equal to k over x, which we got as 4 over x. So this now, it lies on the function of y is equal to 4 over x. So we are going to the same value of 6 because it's still at a point where x is equal to 6, only that it lies on the curve, not on the straight line. Now it lies on this curve. So it means the value of y at point C, it is going to be taken from the curve of 4 over x. That is where we are going to have this, which is 4 over our x at this point is at -6. So it's 4 over -6, which is -2 over 3. So that means at this point, you see y is -2 over 3, or you can take it as a point to say C is at point where x is -6 and y is at -2 over 3. So since we are asked to calculate the distance from B to C, we can use distance formula, or we can use this concept that I indicated here, that the distance from B to C, since it is taken from a vertical line, you can subtract the top part, which is y2 at point 1, minus the bottom part, which is at -2 over 3. So this is going to give us the distance of BC, which is 5 over 3 units, or 1,667. All right. Or you can use the distance formula to say, since I have the point B here, you can take your point B. Since we have got point B, which is -6, 1, and the point C, which is at -6, -2 over 3, like this. We can use our distance formula to calculate BC. Remember that BC as length is equivalent to x2 minus x1 squared plus y2 minus y1 squared. So that is going to give us our BC, which is the square root of, so this can be your first point, your second point. So that means x2 is going to be -6, -1, which is going to be a positive, okay, +6 squared, plus y2, which is -2 over 3, minus y1, which is a 1, everything squared. So this is going to give us BC, still 5 over 3, or 1,667 units. All right, so this is what you're supposed to have on your final answer in this case. All right, so these are the typical questions, guys, that you are supposed to work with, revise on more questions and so forth. So in this case, it was to calculate the length of BC. So it was very, very tricky part, especially on the length. You were given the length from O to D. So by default, you are given the value of x at that point. That was the advantage of it. All right, so let's check what we are given on the other part now. That was question 5.1. This is 5.14. Determine the area of triangle OEF. Okay, wait, we have OEF. Let's check. O to E to F. Okay, we want to have this triangle. Where do we have it? All right, triangle OEF in this case. Okay, this is where we have O to E to F. All right, so let me just remove some of the parts here that we do not need in this case. All right, so this is the triangle that we are formulating in this case, from O here to E to F. So if you are to check, this is a right angle triangle that you are formulating like this. You're actually formulating a right angled triangle from, we have got something of this nature. This is what you are formulating, a right angled triangle. So it's like this. All right. So this is where we are having our point O. This is our point E. This is our point F. All right. So if we are to check here at point E, we are given from point E that this is a -5. So meaning to say, we know the distance from O to E, that is 5 units. It's a -5, so you've got 5 units in this case. So here we have got 5 units from O to E. What about from O to F? What we need from this point here, from this point O to F, to know this distance, we just need to have the y-intercept of this line at point F, of which the y-intercept of this line is the C part of the line. Remember, we calculated the C before, and C was equal to -5. In fact, here we calculated, but here we even proved that C was equal to -5. Meaning to say, at point F, which is the y-intercept, it is at -5. So this is what we are going to have. So from point from our origin to the point of F, we have got 5 units. So in this case, I'm writing the distance, not to say direction. What is the direction? So this is our triangle. This is at -5. This is at -5. So you can have your area. Since it is a right angle triangle, your area is going to be half base times the perpendicular height. So our area, that's half times the base, any of these 5 times 5. So that means we are going to obtain 25 over 25 over 2, which is same as 12,5 square units. Okay, these are not meters, just square units. All right, so this is how you were supposed to determine this area, guys. I just hope this one was direct. So it's a matter of working with more questions that can actually help a lot. So this was the whole diagram that we're given. I just hopefully every part on this diagram we understand. All right, let's move on to the other part of the question, which is on 5.2, where we are dealing with the derivatives in this case. All right, so here we are given 5.2, determine dy dx. Okay, so that's dy dx by means of the rules of differentiation. Leave the answer with a positive. Take note here, your answer is supposed to have positive exponents and in set form where it is applicable. All right, we are given that y is equivalent to the square root of x plus x over 3 minus 2 pi in this case. So what we can get rid in this case is the square root in this case. All right, square root from our laws of exponents, this is same as to the exponent of a half plus x over 3, guys. This is same as 1 over 3x, so that you do not confuse yourself. All right, so now for us to have the derivative of y with respect to x, remember that if we are given to differentiate ax to the exponent of n, this gives us an x to the exponent of n minus 1, where we drop the exponent, then we subtract 1. So this is going to be half. We drop the half here, then we subtract 1 on the exponent. So half minus 1, that's a negative half. All right, this is a third x, which is a linear expression. So you just take the third, that is 1 over 3. So it is going to be plus 1 over 3. Minus 2 pi, this is a constant. So the derivative of a constant is going to give us a 0. So there's nothing that we're going to have in this case. That's a 0 there. So therefore, our dy dx, writing in terms of positive exponents and so forth from our laws of exponents, a negative exponent is same as 1 over. So this is going to be 1 over. Already 2 is in the denominator. So this is going to be 2x to the exponent of a half plus 1 over 3 minus 0. That one, we can leave it like that. All right, let's see. Again, from our sets, we can see that to the exponent of a half, we talked about this before, it was a half, it was a square root before, we wrote it as a half. So if it is written as a half, we can write it as it was written before, as a square root. So this is 1 over 2 square root of x plus 1 over 3. Okay, so that was the whole derivative part of this question. So the question was asking us to determine the derivative, direct derivative, just like that. Okay, so let's check the other part of the question. 5.3, we are given now to consider the function of f of x, which is equivalent to f of x is equivalent to, so this is f of x, which is equivalent to x to the exponent of 3 minus 6x squared plus 9x. Use differentiation to determine the coordinates of the turning points of f of x. Take note, we are to determine the coordinates of the turning points, where we know that at any turning point, the first derivative is supposed to be equal to 0. So we can use this to calculate these turning points to determine the coordinates of the turning point. So let us find our first derivative, then equate to 0 and see what you're going to have. So the first derivative, that's, we are going to drop the exponent 3, subtract 1. So it's going to be 3x squared minus 2 times 6 which is 12x. We subtract 1 plus a 9. So that is our first derivative in this case. So this is supposed to be equal to 0 because we are having equal to 0 here. So 3x squared minus 12x plus 9 is equal to 0. Divide by 3 so that we can solve. This is can be reduced by 3. So x squared minus 4x plus 3, 3 into 9, that's 3, which is equal to 0 in this case. So you're left with a normal equation that we can solve, of which I think we solved this equation before. Okay, anyways, let's just have our two brackets here, x. Okay, factors of 3, when we add, we obtain -1. That's -3 and -1. We obtain -4, sorry. So -3 times -3, that's a +3. -3 plus -3, which is a -4. So this is going to be -3, -1. So x is equal to +3 or x is equal to a +1. So this is how you are going to have your turning points, guys. So at point 3, we can substitute back into the original function of our f of x so that we determine the value of y at that point. So this is how you are going to have the values of y. So you substitute back into the original expression of your f of x in this case. So if we are to substitute the value of x, which is 3, our first turning point is going to be at 3, 0. If we are to substitute in the original equation, our second turning point, which is at 1, it is going to be 1, 4. So these are the turning points that we're supposed to obtain. So you substitute x is equal to 1 into the original equation, this one, f of x, 1 here, 1 here, 1 here, and so on and so on. All right. So now that was the first question. Then 5.32, sketch the graph of f of x showing the turning points calculated in question 5.31 and the intercepts of both axes, which means we need to have a continuation. So far, we have got the turning points, but we do not have the points of intersection with the axis, all right? So that is going to be 5.32. So for the intercepts, we can start with any of those, okay? So we've got, remember, our f of x was given as x cubed minus 6x squared plus 9x. Okay, so for the y-intercept, we know that this is on a condition where x is equal to 0. So when x is equal to 0 here, that's a 0 here, a 0, a 0. So which means y is also equal to 0. So y-intercept, that's y is equal to 0. So it's passing through the origin. Okay, then for the x-intercepts, we know that at that point, y is equal to 0. So if y is equal to 0 here, we can solve for x. That means we are going to have x cubed minus 6x squared plus 9x equal to 0. Okay, so we can factor out x here, which is common. So this is going to be x squared minus 6x plus 9 equal to 0 like this. So factor out or factorize. Here we've got x. Okay, that means we are going to have x and x factors of 9. When you add them, they'll give you a -6. That's -3 and -3. So that's -3, -3. Meaning to say from this concept, x is going to be equal to 0 or x is going to be equal to a 3. Okay, so for this condition where we have got two values of x here, where x is equal to 3 or x is equal to 3 like this, it means that point, it's a turning point also. It's a solution that we are talking about. It's also a turning point. If you are to verify on your turning points, you must have a turning point at x is equal to 3. And this is happening here. At x is equal to 3, it's a turning point. So that is what it means in this case. If you have got a condition like this, that point, it's a turning point and it's also a solution. All right. So this information is enough for us to sketch our curve. So we are going to take this information so that we can have our curve, our y-intercept, x-intercepts, our turning points. All right, so here I'm just going to have a sketch, guys. I'm not going to draw an accurate diagram, just a sketch. All right, so the first thing, okay, let's just have our Cartesian plane first so that I'll show you how you're supposed to sketch this graph here. All right, so this is our X and Y. So if you are to take note here, our graph is given here as this is our f of x that we're given before, this f of x, which is x cubed minus this and so forth and so forth, which is a positive, meaning to say we are supposed to have a shape like this. But now on the solutions, we are just having two solutions instead of three. We are having a solution at 0 here. So let's say this is 0, 1, 2, 3, 4, 5, and so on. We are having a solution at 0. We are having a solution at 3. Why? Because at point 3, this point is a turning point also. So meaning to say our curve, if it is supposed to be like this, we are supposed to have our curve passing through the origin to the turning point, which is our first turning point at 1, 4 there. Then, okay, let me try to have it a little bit this way. To the turning point of 1, then it refers back to the turning point at 3 like this. So it was supposed to be a solution, but then a turning point at 3. Then the graph goes back like that. So this is to show you, this is to show that this point 3 is a solution and it's also a turning point. So this is your y, which is equal to f of x, whatever that you're given. So this is your turning point at 1, which is at 1, 4. So meaning to say this is 1, 1, 2, 3, 4, and so on. So this is just a sketch. So that's your turning point here. Another turning point, sorry. Then the intercepts, that's 0 here. We do not have any other point that is important to indicate. These were the most important points to indicate or to show. All right, so that is what we had from this person, guys. I just hope everything was clear, just that you have to revise as much as we can. So that was our question 5, having a total of 23 marks on everything on question number 5. Okay, so let's check question number 6 in this case. So question number 6, we are given in this case a first part, a trig to prove the trig and so forth. So let's see, that was actually 19 marks on this question. All right, so let's see how we're supposed to attempt each and every part from this person here. All right, so 6.1, we are given to prove the following trigonometric identity. All right, so we are given an identity in this case. All right, so let us just have our identity out. This was one of the most interesting part, yet difficult in another way. Okay, let's see. We are given the sine of A into 1 minus the sine of 360 degrees minus A like this. All right, so this whole part is being divided. Yes, it was divided to 1 minus cos squared 180 degrees plus A like this. All right. Minus 1 is equivalent to cosec of A. So this is what we're given. All right. So the question is, how can we prove? Because this is, we are supposed to prove in this case. And if we are to check on the right-hand side, this is what we have. We've got our left-hand side and our right-hand side in this case. So these two, they are equal. Remember what I said, there is a condition where you can take the left-hand side to prove the right-hand side, that it is equal to the right-hand side, or the right-hand side to prove that it is equal to the left-hand side. So in this case, it's easier for us to work from the left hand. It's the most complicated, the left-hand side. That is where we have a lot of things in this case. Just imagine, guys, on the right hand, we just have a single term. So it was going to be difficult for us to work from the right-hand side, but it's easier from the left-hand side. Okay, so from the left-hand side, we can see that here, we have got the sine of A, which is, for now, there's nothing that we can do with this sine of A. Let's just write it as it is. All right, into 1 minus, okay. Here we have got sine 360 degrees minus A. What does this part mean? Okay, this is in the fourth quadrant. Remember, 360 minus A, this is in the fourth quadrant. And from your reduction formula, from the cast concept, in the fourth quadrant, that's where we've got 360 degrees minus theta. This is where we've got theta. This is where we've got 180 minus theta. This is where we've got 180 plus theta. So 360 minus theta, which is your theta is represented as A, is in the fourth quadrant. And in the fourth quadrant, it's for cos, meaning to say sine is a negative. All right. So this is going to give us minus sine of A. So this was going to give us negative sine of A in this case. All right. We move on to the other part. We have got 1 minus cos squared 180 plus A. We said 180 plus theta. This is 180 plus theta in the third quadrant and is for tan, meaning to say cos is a negative. So this is going to give us a negative cos, but take note that our cos here is squared. So this is going to be negative cos of A, but being squared like this. So take note of this part, all right? Minus 1. So that is what we have on the left-hand side. So now let's see what we can do to simplify further so that this can give us what we are given on the right-hand side, okay? So in this case, we can simplify negative and a negative here, that's a positive. So this is going to give us the sine of A into 1 plus the sine of A like this, okay? Everything over minus cos squared is going to be a positive. Negative 1 when squared is a positive, so it is going to be 1 minus cos squared A minus 1. All right, so this is where we are now. All right, if we are to check here, we've got something that we can relate in terms of sine, the cos here, so that maybe we can cancel with our sine here. So let's see how we can relate this to our sine. Remember from our identities that the sine of squared A plus the cos of squared A is equal to 1, or it can be cos squared, whatever way that you want to write it. So if we are to transpose the cos to the other side, we are going to have the sine squared of A being equal to 1 minus cos squared A. We've transposed cos, meaning to say 1 minus cos squared is same as sine squared. So we've got 1 minus cos squared here, which is same as sine squared. So this is going to give us the sine of A into 1 plus the sine of A like this. Everything over sine squared, which is represented by 1 minus cos squared. So this is going to be sine squared A minus 1. All right, so let's see what we are having in this case. The sine squared means we've got 2 of them, so you can cancel sine into sine squared. If we have got 2, we are going to remain with 1 of the sine. Okay, so this means this is going to be written as 1 plus the sine of A like this, everything over the sine of A minus 1. Okay, so take note that from our fractions, remember I talked about this a lot of time, that if you are given A plus B over C, if it is a single fraction, it can be separated as A over C plus B over C like this. Meaning to say we can separate this fraction into 2. That is, we can separate this as 1 over the sine of A. We are dividing each by sine of A, plus here we are going to remain with the sine of A over the sine of A. That is A over C plus B over C. Each is separated with the denominator of C. Okay, minus 1. All right, so let's check here. The sine of A cancels, meaning to say we are going to obtain a 1 in this case. All right, then we move on to our ratios. We understand that 1 over sine of A, that's a cosec A. So this is going to be cosec A plus 1 minus 1, of which 1 minus 1, that's a 0. So this whole part, we are going to remain with the cosec of A. So this is just going to be cosec A, which is equivalent to the right-hand side in this case. So that is what we are given, of which here we are given that the right-hand side is equivalent to cosec of A. If we check here, the right-hand side is equal to cosec of A. So these were the stages It was an application of your reduction formula, and also the identities, the Pythagorean identity or the square identities, then also the application of your trig ratios to understand that 1 over sine of A gives us cosec of A. It was very, very important application of this question. All right, so let's check the other part that we are given in this case. All right, let's see. That's question 6.2. So 6.1, it was 6 marks. Okay, that's a lot. All right, 6.2, we are now given that if cos theta minus, if cos theta is equal to 3 and tan of theta is greater than a 0, determine with the aid of a diagram. The use of a calculator is not allowed. Okay, so the use of a calculator in this case is not allowed. All right. So let's check how this part was supposed to be done. Okay, what does it mean actually in this case? We are given that here, let's just save our information down. We are given that 5 cos of theta is equivalent to 3. And there is an important part that we are given that tan of theta is greater than 0. Okay. Why are we given this condition? Take note, if you are to check from the ratio of cos, let's say we are to divide by 5 here. We have got our cos of theta, which is equal to 3 over 5. So if we are to use the diagram, in this case, we are limited to say which quadrant are we going to have our diagram in, because from our cast concept, cos is positive in the 4th quadrant and also in the 1st quadrant. So meaning to say we are not sure about where this diagram is going to be. That's why we are given another condition so that it is going to help us to know where exactly are we going to have our triangle. Here we are given that tan of theta is greater than 0, meaning to say the tan of theta is a positive. So where do we have our cos being a positive and also tan being a positive at the same time? This can only happen in the 1st quadrant. In this quadrant, tan is a positive, but take note, cos is a negative. So it can't work because cos is, in this case, is a positive. So we need a condition where both are positive. Tan is greater than 0, meaning to say tan is a positive. Cos is 3 over 5. We already see that it's a positive. So the 1st quadrant is the one that can contain these two to be positive. So our diagram was supposed to be drawn from the 1st quadrant in this case. So you're supposed to have your diagram in the 1st quadrant, where you are going to have it this way. So this is your triangle, where you are going to have your theta here. So remember that also according to the ratio, of course, from our soccer tower mnemonics, this is our soccer tower in this case. We can see that the cos here that we are given is adjacent over the hypotenuse. So that means this is adjacent, this is over hypotenuse. So we can see that according to theta, this is our adjacent, this is the hypotenuse. So which means our adjacent this side is 3. So this is where we have our 3. The hypotenuse this side, this is where we have our 5. So in order for you to simplify whatever part that you are given, in this case, 1 over tan of theta, this cosec squared, we are supposed to fill up our diagram so that whatever that you're going to answer there, it is going to be easier for us. All right, so what is left in this diagram is to find the 3rd side. This can help us to attempt any question, meaning to say we are supposed to apply our Pythagoras theorem to determine the 3rd side, since we are given 2 sides on a right angle triangle. So the hypotenuse squared is equal to a squared plus b squared. That is, you can write as x and y, whatever that you have. So hypotenuse in this case, that's 5 squared is equal to 3 squared plus b squared. So that's 25 is equal to 3 squared, which is 9, plus b squared transpose. This is going to be 25 minus 9, which is equal to b squared, which is 16, is equivalent to b squared. So the square root of both, that's plus or minus 4. But in this case, we are dealing with the b that is on the positive side. In this case, that is on top So this is going to give us a positive B. This is the one that you're going to take a positive answer. So in this case, this is going to be a positive 4. All right. So now we have our triangle. Everything is there. So the first question that you are given on 6.21 was to determine 1/tan of theta. All right. So 1/tan of theta. Let's check how we can determine this 6.21. So 1/tan of theta. Remember from our mnemonics here, tan, theta is opposite over adjacent. So this is going to be 1/opposite over the adjacent in this case, which is going to give us 1 over the opposite according to theta. This is your opposite, which is 4. So that's 4 over the adjacent, which is 3. So that's 1/4/3. So that means 1/tan of theta is equal to 1/4/3 simply means the inverse of, so you're going to invert the fraction. So this is going to give us 3/4 in this case. All right, so that is 1/tan theta. It is going to give us 3/4. All right, let's check another part, which is now cosec squared. So that's cosec squared theta. That's 6.22 cosec squared. Where can we obtain cosec from? All right, where can you obtain cosec from? So we are given in this case cosec squared theta. Remember that cosec is same as 1/sine of theta from our ratios. That's cosec is 1/sine. So squared part, meaning to say we are going to square the 1/sine of theta. So this is going to be 1 over the sine of theta, which is taken from the ratio here, opposite over the hypotenuse. So this is opposite over hypotenuse. That is opposite over hypotenuse. That is 4/4/5. So this is going to give us 1/4/5 like this. But whatever that you determine here is supposed to be squared. So that means the cosec squared of theta is going to give us, remember what we said here, 1 over simply means the inverse of. So if we are given 1 over this is going to be the inverse of 4/5, which is going to be 5/4. So this is going to give us 5/4 in this case. So we've got 5/4 squared. So take note, this is going to be squared. So that means cosec squared theta is equal to 5 squared, which is 25 over 4 squared, which is 16. So this is going to be 25 over 16 in this case. All right, so that was our question 6.22, where we were given an application of our trigonometrical ratios with the use of quadrants that is going to help us in our simplification. All right, so let's check the other part. Sorry for that. Let's check the other part and see what we are given. 6.3, we are now given 2 triangles. In this case, a single triangle that is got another triangle inside. Okay. So in this fig that you are given, we have got point B and C that are point on the same horizontal plane as the foot and of the cliff. All right. So we have got these points B and C 7 meters apart. Then an angle of 70 degrees, which is the angle of elevation from B to, okay, which is 50 degrees. And BC 7 meters apart. Then calculate the height of the cliff AD. All right, so the question is to calculate this height A to D. Okay. So how can we calculate this height from the information that we are given, this only information that we have? All right, if you are to check here, it was difficult for us to obtain this AD direct because in triangle A, D to C, we are just given an angle of 70 degrees, only that we are not given any side. So what we are going to do is we can work with the triangle ABC, this triangle ABC. Try to calculate any of these sides. We can try to calculate either this side AC, or we can try to calculate AB, any of these sides. Okay, if we can calculate AB, then it is going to help us to calculate AD from our trigonometrical ratios. If we can calculate AB, still it can help us also to calculate AD from our trigonometrical ratios again. All right, so in this case, how can we do so? Let us have this angle. Remember, angles on a straight line, they add up to 180. So this angle of 70 and this angle here should give us 180. So to find this one, we are going to subtract 180 minus 70 degrees, which is 110 degrees. So this is 110 degrees. We can determine this angle at point A, since angles in a triangle add up to 180 degrees. So that means angle at A is going to be 180 minus 110 degrees plus 50 degrees. All right, so this is what you're going to obtain, which is 160 from 180, that is 20 degrees. So this is going to be 20 degrees. Okay, so according to this information, we have got 20 degrees here, which corresponds with 7 meters, which in a non-right angle triangle, ABC is a non-right angle triangle. ADC or ADB, these are the right angle triangles, not ABC. ABC is a non. So which means we can apply sine rule to calculate either this side AC or this side AB. So in this case, I'm just going to calculate the side AB. So according to sine rule, we know that if we are given a side and angle, A over the sine of A is equal to B over sine of B. So that means in this case, AB, this is the side that I want to calculate, this one, AB, all right? Or if you want to use, since it's already ABC, let us just also use C over sine C so that we can take it as an advantage. So this is our C here over the sine of C, which is 110. So we are going to have this C here, which is C, which is our AB. So I'm going to write this as AB. So that's AB over sine of C, which is the angle of 110, is equal to, now I have this part that is complete, the 7, which is opposite to 20 degrees. So this is A over sine of A. So that is going to be 7 meters over the sine of A, which is the sine of 20 degrees. Okay, so to find AB, we can cross multiply, or we can simply multiply by sine 110 both sides. Since we are dividing here, we can multiply by sine 110 so that these two can cancel. We remain with AB. So the AB is going to be 7 times, this is 7 sine 110 over 1. So it's same as 7 sine 110 degrees over the sine of 20 degrees. So this is going to give us AB. All right, so with our AB in this case calculated, I obtained something like 19,23234, which is going to be 19,232 in meters. Take note, this is in meters. So with AB being calculated, this can help us now to calculate the side AD. Take note, I have my AB here, which is 19,232 meters. So using this bigger triangle ADB, okay, using that bigger triangle ADB, we are going to take this part only from that triangle. So this is what you're going to take, the bigger triangle, which is at A, D, and B. So at angle B, this is the angle that we are going to work with, the angle at B, which is 50 degrees. All right, so the angle at B is 50 degrees. So this is 50 degrees. At D, that's a 90 degrees. We calculated AB, this side, which is 19,232 meters. So we can see that we are left with a normal right angle triangle where we can calculate this AD, since we are given an angle and a side. So according to the angle of 50 degrees, this side is our opposite, the one that we are given. And we also have the hypotenuse. So which ratio is best to use? Which uses opposite and hypotenuse at the same time? So from your soccer tour, you can have that ratio. So this is opposite over adjacent from sine. So that means the sine of 50 degrees is equivalent to the opposite, which is AD. That is your opposite over the hypotenuse, which is 19,232. So this can help us to calculate AD because sine 50 is same as sine 50 over 1. So cross multiply to determine AD. 1 times AD, that's AD is equal to 19, this times sine 50, that's 19,232 times the sine of 50 degrees. All right, so you're going to multiply these two to determine a value of AD. All right, so AD, if we are to calculate it properly, this is going to give us 14,732566 and so on, which is going to be 733 in meters. All right, so this is our value for AD in this case. All right, so that was it for 6 marks. Yes, so you're supposed to apply the first part, sine rule, then you apply the trig ratios. So like I said, you could have calculated AC. So if you calculated AC, that means you were going to use this triangle now with AC and the angle of 70 now, ADC. Still, you apply the same sine rule, but now you'll be using angle of 70 degrees. So I want you to try it and see if you're obtaining the same answer. You must obtain exactly the same answer like the one that we are having now. All right, sketch the graph of f of x given that f of x is equivalent to sine of x minus 1 from 0 to 360, showing the coordinates of the turning points and the intercepts with axes. Whenever you're given to draw the graph of sine, whatever course or tan, it's best for you to just have your table of values so that you won't mistaken anything. All right, so you're given an interval from 0 to 360. Remember that I told you guys the best way to separate your values of x in this case for sine and cos is by 90 degrees. So this is the value of y or your f of x in this case. So you can separate your angles 0 degrees, 90 degrees, 180 degrees. We add 90, that is 270 degrees. If we add 90, that is 360 degrees. So these angles, they are separated 90 degrees apart. So what you can do, you can simplify by substituting the values at 0 degrees in place of x here. This is going to be sine 0 like this minus 1. Okay, that is going to give us a negative 1. We move on to 90 degrees. That is sine 90 degrees. Take note in bracket minus 1 separately. That is going to give us a 0 and so on. So at minus 180, at 180, that's minus 1. At 270, that's minus 2. At 360, that's a negative 1. So these were the values that you're going to obtain for this graph or from the table. So now you can draw the graph. So in this case, I'm just going to show you a sketch of how your graph can look like in this case. All right, so let us just have our normal Cartesian plane in this case. So in this case, we are having our x values, which are the angles that are being taken from 0 degrees to 360. So that's 0, 90, 180 degrees, 270 degrees, 360 degrees. Then your f of x is these are the values for y. So you can even write it as f of x or you can write it as y, whatever that you are comfortable with. So as you can see, we are only having negative values. We do not have positive because this graph is being shifted. This function, take note, a normal sine wave is supposed to be like this. The normal graph of sine is supposed to be like this. But now, because of the negative 1 here, this graph is shifted 1 unit downwards, which means this point is going to move 1 unit. This point, 1 unit, every point is moving 1 unit downward. That is why we are having this graph now with negative values. Okay, so that is what actually happened in this case. So this is at negative 1. Let's say negative 2, or let's just try to separate a little bit. Negative 1, negative 2. All right, so we can mark our points. If we do not understand, like what I was saying, you can just mark your points 0, -1. That's 0 versus -1. 90 versus 0 here, 180 versus -1, 270 versus -2, 360 versus a -1. So knowing the shape of the graph that you're supposed to have, or the function or the wave that you're going to have, it is going to help you now to sketch this graph, because you know that you're supposed to have a sine wave, which is supposed to be in this form, to the turning point here, then it refers, or it goes back to this point like this. Okay, so this is how our graph is going to look like now at points like, so like I said, it's just shifted from where it was, our graph was supposed to be like this. It was supposed to be like this, something of this nature, but now it's shifted downwards. Okay, so that is the graph of y, or f of x, is equivalent to sine x minus 1. So in order for you to sketch a sine wave, or it's a cosine, or it's a graph of cos, or the graph of tan, just know the basic of the graph. Then when it is shifted, how are you going to apply your graph when it is shifted? So this is the approach that you can have for these trigonometrical graphs. Okay, so that is in this case, the turning points and the intercepts. In this case, we've got our turning points here. The turning point, this one at 90 degrees versus 0, that's a turning point. Also another turning point at 270 versus -2. So that's 270 degrees versus -2, like this. It's another turning point. Then this one is a turning point. It's also a solution. Then the intercepts with the axis, we've got this one at -1. That's 0, -1. Okay, so that's what you are supposed to have. I think everything you can obtain, all the marks that you can have, all the marks that you're given, which is 3 marks. Okay, so that was it, guys. The last part of our question 6.4, having a total of 100 the whole paper. So let's continue to have revisions, especially for those who are to be having their exams in August. Let us continue to be having more revisions as we are preparing for those exams which are ahead of time. So for now, that's it. Till we meet again.